You know, in any real-world application, data is never just sitting still. We're always dealing with growing lists of users, queues of jobs to process, and dynamic maps of settings. Data is constantly changing. And that simple fact, it clashes big time with one of the very first tools every single one of us learns as a developer.
Look, arrays are incredibly fast, but they have this one huge catch. You have to know exactly how big your data is going to be from the get-go. They're fixed. But in the real world, when do we ever have that luxury? Almost never. This fundamental rigidity is the whole reason the Java Collections framework even exists. Okay, let's dive into this.
So here's our game plan. We'll kick things off with why arrays just don't cut it anymore. Then we'll decode the framework's core design, which can be a little tricky. After that, a quick tour of the essential collection types. Then we'll see how modern Java makes them safe. And finally, we'll shift our thinking to performance.
So, to really appreciate why the collections framework is so awesome, you've got to first understand the exact problem it was built to solve. And that problem really begins and ends with the built-in limits of the good old array.
Now, this slide really tells the whole story, doesn't it? On the left, you've got arrays. They're totally static. Once you create one, its size is locked in forever. And it has 0 built-in methods for doing complex things like sorting or searching. But then you look to the right at collections. They're designed for how we actually work. They grow and shrink as you need them to, they compact with powerful, ready-to-use algorithms, and they provide a single unified way to work with them. I mean, there's a reason modern frameworks like Spring almost never hand you an array. They give you a collection. To really master this framework, you have to get its architecture. And that starts by clearing up what might be the single most confusing naming choice in all of Java, the difference between collection with a capital C and collections with an S.
First up, collection, no S, is an interface. Think of it as the blueprint. It defines what it means to be a collection, just a group of items. You will never, ever write new collection. Instead, you use concrete classes like ArrayList or HashSet that actually implement this blueprint. It's the abstract what.
Now, collections, this time with an S, is a completely different beast. It's a utility class. The best way to think about it is like a toolbox filled with static helper methods. It doesn't hold any data itself. You just use it to operate on your collections, to sort them, shuffle them, or maybe make them read-only. This is the how.
And boom, this slide just nails it. Collection is the concept, the abstract idea, the what. Collections is the toolbox you use to work on that idea, the how. I'm telling you, once this distinction clicks, the entire framework becomes so much clearer. Okay, let's look at the hierarchy and see how this all builds up. At the very top, we have Iterable, which is super simple. It just guarantees you can loop over the elements. Collection extends that, and from there, it branches into our 3 main types, list, set, and queue. Now, you're probably noticing that map isn't part of this tree. That's totally deliberate. A map doesn't just store items, it stores key value relationships, so it gets to live in its own separate hierarchy.
All right, now for the practical part. With all these options, how do you pick the right tool for the job? Let's do a quick tour of the main collection types and really pinpoint their specific purpose.
First up is the list. You reach for a list when the order of your elements is absolutely critical. It remembers the exact order you added things, you can access any element by its numerical index, and duplicates are totally welcome.
Think about a user's activity feed or a stream of application logs. The sequence is everything, right? You have to know what happened first, second, and third. Those are perfect use cases for a list.
Next up is the set. A set has one and only one primary mission: to guarantee that every single element it contains is unique. If you try to add a duplicate, it just gets ignored. Simple as that.
So where is this non-negotiable uniqueness so important? Well, when you're managing things like user IDs, email addresses, or a collection of active feature flags, items that by their very nature cannot have duplicates. A set enforces that rule for you automatically.
A queue is a little different. It's less about long-term storage and more about managing a flow of work. It's designed to hold elements before they get processed, typically in a first-in, first-out order, just like a line at the bank.
This is the backbone of any system that needs to handle tasks sequentially. Think of a job scheduler in a background worker, a message queue in a microservices architecture, or an event processing pipeline. A queue is what ensures fairness and order.
And finally, the map. As we said, it isn't technically a collection, but it's probably the most widely used data structure in the entire ecosystem. A map is all about associating a unique key with a specific value, which allows for incredibly fast lookups.
Maps are the lifeblood of back-end systems. They power application configuration, they're used for caching data to avoid slow database calls, and they index data by some unique ID. They are the absolute workhorse for representing relationships.
Now, the original collections framework had a huge flaw. It wasn't type-safe. It was the Wild West. You could easily add a number into a list of strings by accident. Then, a feature came along that fixed everything and made collections truly enterprise-ready: generics.
And this code sample illustrates the revolution perfectly. Before generics, you could put anything into any list. The code would compile without a problem, but your app would crash at runtime when you tried to use that data. With generics, you declare your intent, like list of string. Now, if you try to add an integer, the mistake is caught instantly by the compiler long before your code ever ships. The crucial point is this: generics give you compile time safety.
We've covered what to use and how to use it safely, but there's one more layer to this: performance. Choosing a collection isn't just a matter of convenience, it's a critical design decision that has a direct impact on the speed and efficiency of your application. Now, this slide is basically a cheat sheet that turns complex computer science theory into a practical guide. If you need to grab elements by their position instantly, ArrayList is your answer with its O of 1 access. If you need to check if something exists or look up a value by its key at lightning speed, HashSet and HashMap are your tools, also O of 1 on average. But if you need your unique items to always be in sorted order, you'd pick a tree set, understanding that the O of log n performance is the trade-off you make for that feature.
So let's bring it all together. We started with the idea that collections are the dynamic solution to rigid arrays. We cleared up the whole collection versus collections confusion. We saw that your choice, list, set, queue, or map, has to be driven by your data's purpose. We know that generics are non-negotiable for writing safe code, and that every one of these choices has real performance consequences.
And that leads us to the final and most important idea. When you choose between an array list and a hash set, you aren't just selecting a data container. You are making a conscious design decision, a decision about order, uniqueness, and performance that demonstrates a professional understanding of your data and what your application truly needs.